Welcome to Disruption Dialogues Podcast Season 2. Listen to the influential leaders and trailblazers from around the world as they share invaluable insights to navigating the fifth industrial revolution.
Hello and welcome to another episode of Disruption Dialogues Season 2. I'm Robert Outram, Vice President for Chemicals, Materials and Food for the Europe, Middle East region at Markets and Markets. Today, I'm having a conversation with Dr. Lars Kissau, President of the Net Zero Accelerator at BASF. Lars, a 20-year veteran at BASF, is revolutionizing the company through his new division. Focused on renewable energies, the circular economy, and reducing CO2 emissions, Lars is driving BASF forwards towards the ambitious goal of net zero by 2050. With his experience and dedication, he's shaping a sustainable future in the chemical industry. Thank you, Lars, for joining us today.
Thank you. It's a pleasure to be here.
Fantastic. So, Lars, we're going to cover three topics today, focus on decarbonisation, the circular economy, and then finally moved on to the hydrogen economy. So starting from the top, the topic of decarbonisation, and as we mutually agreed, as a chemical company based on organic chemistry, your fundamental chemistry is based on the element of carbon, so therefore cannot be decarbonised. So when we're really talking about decarbonisation here, we're talking about absolute carbon dioxide reduction. So with that in mind, the first question, BASF has targeted 25% reduction in absolute carbon dioxide by 2030. Would you call this a rather ambitious target? Is it realistic? And also, how does BASF plan to achieve it, especially given the current economic scenario, the war in Ukraine and the energy crisis?
Well, Robert, I think it's ambitious and it is realistic. Maybe to put this in perspective, 25% as such doesn't sound like a lot, but we have to go back a little bit and look where we started. As a company, we started measuring and reporting our CO2 emissions in 1990. And back then, we had, as a company, about 40 million tons of emissions, and we were about half the size of today. Since 1990 until 2020, we cut our emissions in half and doubled in size. So that was already a significant move. And now by 2030, we're looking to cut them again significantly. Actually, we're looking to cut the emissions by 50%, but then we're also accounting for organic growth that we will have as a company. And we need to overcompensate that. So as a net result, we expect 25%. If you look back, a lot of the emissions that we reduced since 1990 looked like low-hanging fruits from today's perspective. So what we have ahead of us is pretty ambitious. That's why I would say it's a very ambitious target. It is realistic because actually set it based on a very concrete plan. You already said it. We don't really want to decarbonize because we need carbon in our product. But what we're talking about is eliminating CO2 emissions. We will do that by focusing on switching to renewable energies rather than burning fossil fuels. We'll do that by changing into some new innovative CO2-free technologies. And of course, we're also looking long-term to replace fossil raw materials with recycled or renewable raw materials. We really want to shape this transformation and see this also in a competitive environment. And for this, it needs also I would say a stable regulatory environment, and we need a openness that promotes innovation and also an openness to different technologies. In that context, it's certainly difficult if we are facing lots of changing regulations or in huge increase, as well as a political environment where sort of a bias is towards one or the other technology. So I think that's for me in the current environment, especially when you talk about the EU. With the energy and economic crisis, we actually hope for a bit more openness towards new technologies and also policy-wise a bit more understanding that it takes time to develop these new markets.
Yeah. Okay. You mentioned the transformation there, and then obviously all this has got to be paid for.
Yes.
How do you balance the economic viability of this transformation, the initiatives you're putting in, with the need for sustainability and environmental responsibility? I mean, basically, in other words, how can you be profitable and yet achieve net zero targets?
I think there's a couple of fundamental things. I'm convinced that this transformation for us and for many other companies will only work if there is a business case. It will not work. It will slow down if it turns out to be a bad business idea. But I think it can be. We assume that by 2030, you will have a market where the demand for products with a low carbon footprint, basically, so let's say CO2-free products, will be larger than the supply. So we want to be in that market. We want to capture that opportunity and ideally be the first one to supply our customers with products that are CO2-free, that have a lower CO2 footprint. So when you see that customer demand, I think that's a good business case to go for, and that's why we think there is an economic viability. The other thing that, of course, helps is, since we're active globally, we look at our opportunities, the project ideas, the things we can do from a global perspective, and prioritize very clearly. And we will do those things first that seem to have a business case earlier. There are some things that we have in our pipeline that probably before 2030 will not work, but afterwards we see a chance for a business case, so we'll start them a little bit later. But it needs to be economically viable very clearly. You also have to consider, as a chemical industry, we are really in the middle of what we call a double transition. We need to become climate neutral, we need to become circular, we need to innovate towards safe and sustainable chemicals, and we have the digital transformation. So there's 4 transformations going on in parallel, and all of those are affecting the business model, are affecting profitability, and we try to make that do that in a way that we actually capture opportunities from that.
Okay, brilliant. Okay, and obviously the chemicals and materials, they're playing a vital role in any product. Literally anything we see, feel, touch, chemicals are involved, and all the value chains are so much intertwined with the chemicals and materials industry. How can the chemical industry engage with other sectors, other stakeholders to create a more sustainable and decarbonized future?
You said it. The chemical industry, of course, has to manage its own CO2 emissions as a very CO2 intensive industry, but it's actually very key to the transformation of other industries. I mean, if we look at some of the products that we also market, they're talking about insulation foams for energy efficient buildings that will help to decarbonize the housing sector. You have lightweight components for transportation for cars. Yeah. There's a lot of chemistry in wind turbines or battery materials for e-mobility, sustainable agriculture. So lots of things in our portfolio actually help other sectors make that transformation towards net zero. What our ultimate goal is really, and I mentioned this, is produce products with a zero product carbon footprint. And I think where we engage with our other industries is by offering those products, we are helping them make products that have a lower carbon footprint. So this is really a key part of this interaction. And what we have done actually, and this also ties into the whole digital transformation thing. We have about 45,000 sales products as a company. And for each one, we have the ambition to provide our customers with a product carbon footprint. So when they buy it from us, that they also know what the product carbon footprint is of what they're putting into their products. Calculating that manually for 45,000 products is not doable in a realistic amount of time. So we, since it was not available in the market, we developed an in-house tool, a digital tool that does that in parallel, real time for all 45,000 products. So we are today able to provide our customers with the product carbon footprint. So when they buy our products, they can calculate also their footprints. And this will help also our customer industries drive towards net zero.
Okay, that's fantastic. I know when I've been talking to some chemical companies now, their procurement teams, they're definitely, it used to be price, sustainability of supply, reliability, all the rest of it. And now they really are factoring in when they're buying products, that carbon footprint into that purchasing equation. So, so great to hear that. Okay, I mean, BASF, you're a huge consumer of energy, absolutely huge consumer of energy, a bit like the chemical industry as a whole is a huge consumer of energy, just like the cement industry, things like that. What's your sort of strategy going forwards with respect to that energy? Do you buy in green energy or do you create your own energy?
Or both. We call it a make and buy strategy. We basically, like I said, green energy is a future strategic raw material, and we need a diversified portfolio, and we need a reliable supply. So we are doing both. We are, for instance, investing into our own renewable power assets right now, particularly offshore wind farms. But we're also purchasing power on the market through long-term supply agreements with plant operators. And I think what's really key for us here, because we want to drive the transformation, one key criteria for us when we purchase power is additionality. So we're looking for green power from new assets that are being built, not from existing assets, because that will basically help to drive greenification, if you will, of the grids.
Yeah.
Give you an example for the make options. We have realized we're right now constructing on the Dutch North Sea a wind farm together with Vattenfall called Hollandse Kust Zuid. It's 140 turbines, capacity of 1.5 gigawatts, and it's currently the largest subsidy-free wind farm in the world. So that's one thing that we are actually quite proud and quite happy of to already have this. We're not only going for offshore wind, though. We also have a solar farm at our plant in Schwarzheide in the eastern part of Germany that's already online since last summer. And we are on the buy side also progressing well in North America. We procured about 250 megawatts of wind and solar capacity through some purchase agreements with Dawn Solar and EDF Energy Services. We have a couple of supply agreements also in Texas. And even in China, we have made some very significant progress with some long-term supply agreements with the state power investment corporations and Brookfield, and those actually help to supply that new site that we're building in South China and make it basically completely supplied by renewable power when it starts up in 2025. That has been quite a huge effort, and we have in 2022 actually managed to have about 16% of our global power supply already supplied from green power. And the ambition is that basically by 2030 we will have what we have today as power demand. We'll have that completely supplied from green power. On top, we actually expect an increasing power demand because a lot of what we are fueling today with fossil fuels will be replaced by electrification. So our power demand will actually increase beyond what we see today.
Okay, Lars, just very quickly, you touched a little bit on digitalization and some of the tools you're using. Very briefly, how do you see the digitalization helping the transition towards net zero emissions within the chemical industry?
But I think what I mentioned before, this tool that we developed, we call it SCOT, Strategic CO2 Transparency Tool.
Okay.
We developed that because we are convinced that in order for customers to buy products, in the end, they will want to have a choice. They will want to buy from us or from our competitors' products with a low carbon footprint. Now, of course, everybody needs to be able to calculate, and there's actually there are ISO norms of how do you calculate product carbon footprints, but everybody needs to be able to calculate them, and they need to be comparable. And basically what we did in order to be able to calculate, as I said, we developed the tool. So this takes care in a digital way of calculating them. And when we make this tool actually available through some IT companies to other companies, basically to use it, because it's not our intention to be different. If the customer is getting product carbon footprints in the end that are different depending on who calculates them, they have no comparison and they become essentially useless. So ideally, as a chemical industry, we can agree on one way of calculating, and it doesn't have to be our solution. Maybe there's another solution. Right now, we don't see viable other solutions in the market, so we'd be happy to share our solution with other companies. And since that's sometimes easier to do with an IT company, there's several IT companies that are working with us, and a couple of other chemical companies have actually also taken up this solution. And I think this is one way how the chemical industry can really, using digital tools, help to accelerate the transformation if we have that as a baseline.
Right.
Another one that is quite significant, I think, is the traceability. Digital product passports, something that I think will come in many industries. Or for instance, when we talk about automotive industry and batteries, the end customers, a lot of time will want to have traceability through the whole supply chain of where the materials is coming from. And again, that is something that we can only do using digital tools. To really provide that trust and transparency that the materials contained in your product are actually traced back to a certain source that you are comfortable with as an end customer.
Okay, certainly standardization across the industry. Really interesting to hear that you're going to potentially open this up to other chemical companies as well. That certainly makes a lot of sense. Now, just moving on to our second topic now, the circular economy. As a chemist myself, I'm sometimes a little annoyed that, plastics has almost become a bit of a dirty word. It's such a useful material, but yet it's invaded our oceans. It's in, we find it in mountains. We've even found it in the human bloodstream. The researchers from Amsterdam University Medical Center found traces of sort of common synthetic polymers. larger than 700 nanometers in blood samples of healthy individuals,
Right.
really emphasizes the need that recycling is imminent more than ever before. What are the initiatives and ways in which chemicals and plastics manufacturers can ensure higher recycling rates and more circularity?
Yeah, first, I would say I really appreciate the way you look at this. I think plastics are an essential part of modern life, and they create
Absolutely.
a lot of benefits, whether you talk about clothing, shoes, medical applications, construction. I mean, everywhere there is a huge benefit, and we shouldn't miss out on that. The real challenge, I think, comes with the way the plastics are managed at the end of their life cycle. From the numbers that I've seen, only about 20% of the plastics that are produced are actually recycled. The rest is incinerated, landfilled, or worst case, like you said, winds up in the ocean. And of course, that's the problem. We have to improve how we manage the waste and how we recycle it. And there's a couple of initiatives that we look at. I mean, first thing, you don't want persistence in the environment. So one avenue that we can look at is biodegradability. So, and this is something that BASF has researched many years ago with a couple of different polymers that we have called EcoFlex, EcoBio, that are biodegradable. So if you have an application where somehow the polymer remains in the environment, it will biodegrade and not persist. And I think that's one avenue that we can pursue. The next one, I think this is an important one, is mechanical recycling, basically collecting the waste, sorting it, and trying to reuse. That comes with a lot of challenges, especially since the reuse requires you to sort it very well and have basically an almost pure stream after sorting. And here, what we can do is we can certainly help with stabilizers to improve the properties, but also some tracing materials that help basically a spectroscopic identification for the sorting machine, so you can improve the quality of sorting and help mechanical recycling achieve higher rates of recycling quota. The final one, I think this is one that the chemical industry is now pouring a lot of money and effort in, including us, is chemical recycling, where you really take the plastics, even mixed plastics, you break them down to the elemental components, and you get the carbon and you do chemistry with it again. So I think as a combination of all those methods, I think we can manage the plastic waste issue. But you said it's really the top thing to work on. The benefits of plastics are huge, and we have a growing population globally, and they will need plastic materials, but they will need a waste management that works.
Yeah, absolutely. And it's a tricky one, because you've got the standard polymers, obviously, that you can recycle, and then these biodegradable ones that don't really have at the moment a recycling sort of value chain in place for some of these. Some of these polymers, it's a tricky multiple ways to manage this, and not everyone has the same outlook. I mean, maybe you can throw some light on some of BASF's initiatives within recycling and the circular economy. You touched on a couple there. Are there any more?
Yeah, there's a couple. I mean, I think fundamentally what we're trying to do is really with the topic of circular economy. We need to decouple the growth of a company, the growth of an economy, from the resource consumption. I mean, we all realize that's limited. So we have to reduce the resource consumption, reuse, recycle. That's really the key. And along those lines, as I mentioned, we talk about additives that help improve the mechanical recycling. We are also a founding member of the Alliance to End Plastic Waste, which focuses on developing infrastructure for waste collection in several companies, promoting recycling methods, also education and engagement on stakeholders, and also cleaning up areas that are heavily impacted by plastic waste. So that's also one area that we're working on. We also have a number of partnerships where we're trying to build support for an important concept, which is called mass balance. If you look at the scale, let's say typical petrochemical operation, say a modern steam cracker has a scale somewhere between 1 million and 2 million tons of ethylene, and obviously needs that similar amount of raw materials. If you look at the mechanical or chemical recycling plants and their output, it's 1 or 2 orders of magnitude slower. So I think where we can really make a bigger contribution, and where we are actually having a bigger initiative, is bringing chemical recycling to scale, and then also replacing with that fossil raw materials. So we really try to decouple our growth from consuming virgin carbon, really trying to get more recycled carbon into our systems.
Okay.
And of course, there are some specific recycling loops that we're building, and I would say there's polymers, for instance, that go into mattresses, that we can try to recycle. There's also certain other polymers that you can basically remonomerize. So there's different chemical approaches that we are investigating, trying to fill our value chains with recycled carbon.
Yeah, I mean, I really see the future of the recycling as being the chemical recycling. I mean, as you no doubt know, the mechanically recycled plastics, they have limited reuse potential, and you know, the big advantage I see for the chemical recycling is you're back to the monomer, so you can create essentially virgin plastic again from it, which is fantastic. You know, whether it be the pyrolysis route or the enzymatic hydrolysis. Again, there's multiple avenues that you can go down within this sort of chemical recycling avenue. What do you see as the state of the art for chemical recycling? You know, what technologies do you think will win the race to recycle? And you know, what is the commercialization status of BASF's ChemCycling technology?
I mean, fundamentally, I would say chemical recycling will be a very good complement to the mechanical one. There are certain things that if you can sort them well mechanically, let's say PET bottles, I mean, that's something that certainly should be expanded. But chemical recycling will no doubt be a great solution, especially when you talk about mixed plastic waste that is difficult to recycle. I mean, one example is multi-layer food packaging. You go to the supermarket, your cheese and meat packaging, multi-layer, where every layer has a different function, and we all benefit. It reduces food waste. It's actually a very ecologically sensible to package food that way. But of course, they're very difficult to recycle mechanically. So that's a typical application where we see for chemical recycling, you bring it. Right now, I would say state of the art is pyrolysis. You bring it into a pyrolysis plant, you create a pyrolysis oil, and then with a little bit of workup, you bring it back into your chemical operations. And I think this is what we see as one major area. These mixed materials that are difficult to recycle, and a lot of applications actually mix different polymers. And I think we have, if I look at our portfolio right now, we have about 200 products that are actually based on recycled raw materials. Again, using that mass balance approach, because the volumes that we have today are just too small. So you're mixing it with your other raw materials at the beginning of production, and you have a traceable system internally to make sure that whenever you sell a product, the corresponding amount of recycled raw material has been used. And I think this is one way that we will build up the business. We'll go beyond the 200 products very soon, and we see the strongest demand actually from applications that are very sensitive to performance. If you talk about, let's say, medical applications, some functional textiles, automotive, temperature-sensitive applications, all these applications need high performance of the polymers and struggle if you have any sort of performance degradation through mechanical recycling loops. I think, and those are the areas that are first to pull when it comes to products based from chemical recycling.
Okay, that makes sense. I mean, what do you think is the best approach to on the road to net zero? I mean, again, lots of options out there. I've got to admit myself, I don't like carbon capture. I think it's a license to sort of carry on as normal. I think there are better options out there, but you know, what's your opinion? Do you see recycling, circularity alone as the best mix, or a mixture of carbon capture, emissions reductions technology plus recycling? How do you see this panning out?
I'm a fundamental believer in innovation, and I really think what we have now, this huge challenge globally, is a big driver for innovation. So what we need is basically right now the openness to entertain all these different options in parallel. I agree that, say, carbon capture is maybe a temporary solution, but not a long-term fix. I mean, long-term, being a chemist, CO2 is a carbon-containing molecule. I would love to use that as a raw material.
Absolutely.
So dumping it and sequestering it somewhere is maybe a temporary solution to remove CO2 from the atmosphere, but it cannot be the only solution long-term. And likewise, many of the other solutions that we talk about will contribute, but they might not exclusively be the one. But what happens in any case, as everybody is developing certain technologies, the competition will trigger innovation. And it's, I would say, from today's perspective, almost impossible to say, well, what will win the race? So we just have to engage in different areas and believe that there is a lot of innovation power that companies and research institutions will still unleash.
Okay, brilliant. Lars, I'm going to skip ahead to a really important topic, which is the hydrogen economy. It's something that Markets and Markets we've been looking at intensely. And again, there are many different ways as to, first of all, hydrogen production itself, with
Right.
all the different colors, the gray, the blue, the green, and even the white, of course. But what do you see as the winner for? Obviously, green hydrogen is the game changer here. What
Right.
do you think will be the winner within green hydrogen? You have different technologies. You have PEM electrolyzers. You have solid oxide electrolyzers. You have alkaline electrolyzers. How do you see this green technology shaping up, and who will be the winner?
Well, I would say quite similar to what I just said on a general innovation piece. Certainly, green hydrogen will solve a lot of issues provided we have the amount of green energy that we need to make it. If I look at the current size of the hydrogen market, which is basically driven by the chemical industry and by refining, and the future use of hydrogen, the hydrogen market is looking to be very big. So we will need a lot of energy to do that, and that needs to be built. So that ramp up into a hydrogen economy will take some time, and it will not work if it's only green hydrogen. I think for some transition period, we will need to use blue hydrogen, or maybe move away from the color coding entirely and just classify hydrogen according to the carbon footprint that it comes with.
Right.
And I think what we are looking at, I mean, of course, we're looking at a green hydrogen. We're also building a PEM electrolyzer here at our main site in Ludwigshafen to see how we integrate that technology. But I see I also expect there will be a lot of innovation, further improving the production technologies for green hydrogen. And in parallel, we're looking at other technologies. One that we are also looking at is called methane pyrolysis, where you basically split methane into hydrogen and solid carbon. Big benefit of that is that you get hydrogen that is CO2 free. I mean, you produce solid carbon and you don't produce CO2. But you only need about a fifth of the green energy to run that process compared to production of green hydrogen.
Okay, so interesting.
I think those are things that we're looking at. In the long run, if we really have a sufficient amount of green energy, I think the largest part of the market will be green hydrogen. But until then, and I think that transition phase for me is probably another 15, 20 years, we will see a lot of other technologies competing. And of course, we also have to acknowledge that this right now is significantly driven by a lot of subsidy programs around the world, with different countries vying for the leading position of the lowest production costs for emission-free hydrogen.
Yeah. Okay. Yeah, I agree. I think those subsidies, once the industry gets established and the electrolyzer costs come down, then those subsidies will probably be removed in due course. I mean, you mentioned
and they should be, and they should be. I mean, I think this is something. Subsidies for me is something that help us to scale a new technology. But as an industry, we shouldn't be asking for long-term subsidies. I mean, this is not no country in the world can pay for that. It doesn't make sense either. You need to be competitive. So subsidies to ramp up a new technology is fine, but then, like you said, it should really be ramped down in the future.
Exactly. I'd agree with that. Now, you mentioned some timelines there, Lars. 20 to 30 years. Do you think green hydrogen adoption will be smooth? Do you see some hiccups or challenges for the chemical industry? And when really do you see the tipping point for green hydrogen coming in?
I think 2030 is probably a time a point in time that a lot of people look at. I mean, the transition to green hydrogen requires several things. Of course, we talk about investing into the production capacities and getting the energy, but the other thing is also we need the infrastructure. Not at every site that needs hydrogen will you have enough space or have the ability to locally produce it. So in many areas, and I'm just looking at Europe, there's a bigger discussion on having a hydrogen backbone, a pipeline network to try. So I think that all needs to be coordinated. And I think with all the projects that are going on, 2030 roundabout looks to be the time when we will have a base load or a starting grid for hydrogen pipelines. There will be some first fill volumes to start. So I think 2030 is probably the point when this really starts. Before that, you will see a lot of investment to prepare, but it all needs to come together on the supply side, on the infrastructure side, and also on the demand side.
Yeah, the infrastructure thing's a really important piece of this, and I think a lot of lessons have been learned from the automotive industry, and particularly with things like electric vehicles. So we have a guy at Markets and Markets that worked for Nissan, and he remembers selling the first electric vehicles from Nissan, and the charging points, the infrastructure just wasn't in place. And now we're seeing, I think the automotive industry in particular has learned a lot from that, in that they're putting the infrastructure in place before they even start building the vehicles now. And I know BMW are doing a little bit in that space to make sure that the cars that potentially could run on hydrogen are being introduced with that infrastructure in place now.
And I think especially the cross-sector interest in hydrogen will require some time to ramp up the infrastructure. I mean, the chemical sites either have local production or they're probably pretty easy to connect to pipelines. But we're not the only industry looking at hydrogen. And if you have mobility and housing and all these sectors looking at hydrogen, you will need a distribution grid, and especially for transportation, then also the filling stations. So that will take some time to build that. But I think by 2030 we will have a certain base, and that's also the time we need it on the supply side to actually establish the projects to make the emission-free hydrogen, and also to develop the new technologies. I mean, what I mentioned before, the methane pyrolysis, things like that, are in a developing stage. They will probably need another couple of years before they're really commercial scale.
Okay, brilliant. And we've briefly touched on a few other industries there, Lars, but there are mixed opinions as to where hydrogen really makes sense as a fuel or an energy source. Whether it be automotive or heavy industry. Where do you really see the major applications for hydrogen?
Well, if I start in-house, I think chemical industry is of course a major consumer. We need it really as a structural raw material. I mean, BASF alone consumes about 1 million tons of hydrogen every year. So we are quite interested to have that, and we see additional use in the chemical industry already. I mean, if we talked before about the temporary use of CCS and then using CO2 as a raw material. When you talk about that, you're effectively talking about using hydrogen to activate CO2, and then you do your chemistry. So long term, we see a significant increase in demand from the chemical industry for really closing the value chain and taking CO2 out of the atmosphere and tying it up in molecules for longer term. That is certainly a significant part. I think also hydrogen as an energy vector will become important to stabilize grids. I mean, we have a massive change towards renewables that's affecting the stability of electricity grids. I think hydrogen will play a role here. And of course, like you said, transportation, certain sectors of transportation look like they are probably getting to an efficiency point better with hydrogen than with electricity. Probably passenger cars are more going to be likely to be electrified. But I think that, again, is a topic where innovation might really drive it forward, and we see which technology wins.
Okay. Yeah, I mean, I think I'd agree with that. And we're really, at Markets and Markets, we're really predicting that the chemical industry will actually be driving this forward, as opposed to the automotive mobility area. Lots of demand for potentially green hydrogen, things like fertilizer production, sorbitol. I mean, there's lots of different molecules that, as you rightly say, can use this green hydrogen for its production, and has a decent business case, economic business case to do so as well.
Right.
Okay. Any further points, Lars, you wanted to mention before we wrap up on these topics?
No, it's been a real pleasure talking to you. I think this is really a topic very close to my heart. I think that we need to really have all these discussions about the transformation. It's a huge effort that is difficult to organize, and it requires a lot of stakeholders to get together and discuss how we're going to do this. So I think it's a great opportunity. Thanks for inviting me, and I look forward to having many more of these discussions.
Well, it's absolutely a pleasure having you, and thank you everyone for listening in. This was a discussion with Dr. Lars Kissau, who's the president of the Net Zero Accelerator at BASF. Thanks, Lars, again. Stay tuned for such interesting episodes on Disruption Dialogues.
Thanks for tuning in. If you want to know how you can navigate and thrive in this disruptive era, subscribe to Disruption Dialogues on your go-to podcast channels and stay tuned for more interesting episodes.